Our learning objective is to use properties of equality to isolate variables and solve algebraic equations. When we talk about isolating a variable, that simply means to get the variable by itself in order to find the value of x. And solving that algebraic equation tells us that once we find the value of x, that is the value that's going to make our statement true. So when we look at 2x plus 2 is equal to negative 4, we want to know what value of x is going to make the left side of this statement equal to the right side, which is negative 4. So before we jump right into this algebraically, we're going to use algebra tiles to model the situation. So our key says that our x terms are going to be represented as a green rectangle, our constant as a yellow square, and then the negatives of these same type of terms is going to be represented as in the color red, so that we can tell the difference between the two. So before we represent it as algebra tiles, let's just rewrite it in each color. So 2x is represented in green, plus 2 is positive, and it's a constant, so we'll write that in yellow. And it equals to negative 4, which is also a constant, but it's negative, so we write that in red. Now that we have it written in the right colors, now we can use our algebra tiles to represent it in the correct colors as well. Okay, so our 2x is represented as two rectangles, and just for the sake of space, I'm going to write them sideways. Plus 2 tells me I have 2 yellow. Okay, and for my equal sign, I'm going to use a line to separate the two sides, and that equals to negative 4, which is still 4 squares, but they are red. Okay. All right, so when we look at this problem, we have represented it using algebra tiles, and my job is to get x by itself, which is what isolate tells us to do. Now, in order to isolate x, that means that positive 2, or those 2 yellow squares, have to definitely go away. So if I have positive 2, our understanding of zero pairs tells us that positive 2 means that I need a negative 2 in order for them to go away, because zero pair says that if I have a positive and negative of the same value, they automatically cancel each other out. It's like if I get a cookie but then I eat it, it's gone. So I have 2 cookies. So now what happens when I eat them? Okay, they both go away. Now, I'm not done with this step, because what I do to the left side of the equation, I have to do to the right side in order to keep it balanced. So if I put negative 2 on the left side, I have to do the same thing on the right side of this equation so that it remains balanced, because we don't want our equation tipping over. Okay? All right, so let's look at it. Now, in order to see what I just did, I want to rewrite this what I have left over. So now I still have those 2 x's which equals to, now if I look at this, I can clearly see that I have 6 tiles left over, but my job is to figure out how much does 1x equal. I have 2x, but how much does 1 equal? So I'm going to split these 6 tiles into 2 groups to see how many red tiles represents just one of my x's. So let's see. As I write them, I'm just going to split them into 2 groups. So that's 2, 3, 4, 5, and then 6. So if I look at this, I have separated those tiles into two separate groups. So what I see is that 2x's is equal to -6. But if I split this into two groups, that tells me that 1x is equal to -3. Okay, so my answer tells me that 1x is equal to -3. I have isolated my x terms. Now, if I look on this side, I'm going to be doing the exact same thing, but I'm going to do it algebraically without the algebra tiles. Now, I still like to write the equation in my colors so that I can see that same representation. So 2x plus 2 equals to -4. Okay, so I can still split these on two sides, so I can see my job is to isolate the variable, or in other terms, get x by itself. Okay, so again, I still have this +2, and how did I get rid of it over here? I added -2 so that I could create a zero pair, which is the same thing I do in the equation. Adding -2 is the same as subtracting 2. So remember, what you do on one side of the equation, you have to do on the other side. Okay, so now my zero pair says +2 and -2, which means that these are canceled because they equal to 0. So 2x equals, I had -4 and I added a -2, which gives me -6. So I know that 2x's is equal to -6, but my job is to split this into two groups because I have two groups of x that equal to -6. So I want to know, well, how much does one group equal? So in order to do that, another word for splitting something is to divide. So once I split this into two groups, I no longer have 2x's. I only have 1x is the same as, and some people like to draw a line here just so that we can see the different steps. So 1x is the same as -3, which is the exact same answer that I got on this side. Okay, so my job was to use properties of equality to isolate variables and solve algebraic equations. So let's see if I actually solve this. By checking this, I'm going to see if the value of x that I found is going to make my statement true. So let's see. Okay, so in order to do that, I'm going to check my equation. So the equation says 2, but instead of putting x here, I'm going to replace it with what I found, which was my answer, so 2 times -3 plus 2 is equal to -4. Now I don't necessarily need the colors anymore because I'm just going to solve this equation straight out, but I wanted you to see that this -3 replaces this value of x that we were looking for. Okay, so everything else in my equation stayed the same. The only thing I did was replace x with -3. Okay, so now let's solve it and see what we get. 2 times -3 is -6 plus 2 should equal to -4. Okay, so if I have -6, I owe somebody $6, I pay them $2, I still owe them $4. And does -4 equal Negative 4? Yes. So therefore, I have a true statement and I solved my equation correctly.